So we're going to take a look at, this is Chapter 3 review. How do we know which method to use? One method we have is called square roots. If we have an equation that's already written as a quantity squared equal to a value, we're just going to go ahead and use square roots. Square roots means we're going to take the square root of both sides. But the way to do that best is to first of all not have any coefficient in front of this. So what will we do here in this example? Divide by 3, so we're going to have x minus 2 quantity squared equals 9. Kind of light. So now we're going to go ahead and take the square root of both sides, and we'd have x minus 2 equals, what do we have to put any time we are taking the square root with an equation? Plus or minus 3. So now our solutions are going to be x equals 3 plus 2 and negative 3 plus 2. So our solutions then are going to be x equals 5, or x could be negative 1. That's the fastest way to do that problem. Now, I could have multiplied all this out, got a set equal to 0 and factored it, and I would have gotten the same answer. But this is much easier to do. Alright, next step. Factor if you can. If we have an equation in this type of form, we're going to find a times c. So in this case, what's a times c going to give us? We're going to get negative 8 when we do a times c. Now we want to see, are there factors of that a times c that will add or subtract to be b? What are the factors of negative 8? You can even treat it as positive 8 if you want. What are the factors of 8? 8 and 1, 4 and 2, 2 and 4. Okay, will any of those combinations add to give us a 7? Yeah? If we use negative 8 and positive 1, right? Wouldn't those two combine to give us a negative 7? So that tells us then that I need the outers and inners to be this in order for this to be factorable. I set up the double parentheses. I'm going to put my 2x here, my x here. I know I need to have a negative 8, so what am I going to put here in order to get that negative 8 that I need? Minus 4. And then on my inners, I'm going to need to have a positive 1, so I'm going to have to put plus 1. Before you solve this, you're going to want to check. That's 2x squared, that's good. That's negative 8x plus 1x, that's negative 7x. Negative 1 times positive 4, positive 4 times positive 1 times negative 4 is going to give me negative 4, and so that works as well. And so what are our solutions going to be then? Take this over and divide. What do you get? Negative 1/2, and what else? 4. Now, the nice thing is, remember how we programmed our quadratic formula. Let's say that we got a little confused on that one, and we want to make sure we did it right. Well, I can go to my program. What's my a value? 2. What's my b value? Negative 7. My c value? Negative 4. And my answers are supposed to be 4 and negative 0.5. And so we did it right, okay? All right, number 3, completing the square. When we have the quadratic in this form, and a is 1, and b is an even number, completing the square will be easy, okay? But I only want to complete the square if I can't factor. What are the numbers? See, if I multiply my a times c, I get 12. Factors of 12 would be 1 and 12, 3 and 4, 2 and 6. I think that's in all of them. Will any of these add or subtract to give me 6? No. This cannot be factored. That means I'm going to have another method. And a good method to use would be completing the square because my a value is 1 and my b value is even. So to complete the square, I'm going to have x squared minus 6x. I'm going to go ahead and take that 12 over. What do I need to have here to complete the square? 9. So I'm going to have add 9 here, add 9 here. Double check and make sure it's the same thing you started with. It is, because if I subtract 9 from both sides, I have the exact same thing I started with. Go ahead and factor. This is x minus 3 squared. This is negative 3. I take the square root of both sides. I have x minus 3 equals plus or minus I radical 3. I need to add 3 over here, so I'm going to have x equals 3 plus or minus I radical 3. Now, I want to show you something here, because a lot of times people are like, well, why wouldn't I just use my quadratic formula program? Well, watch what's going to happen. I put it in. Look at those answers. Are these going to be exact answers? No, because this is irrational. The only thing I can see is that this part's right. Now, I could check it. What should this be equal to, this 1.73205? Radical 3. So let me check it. Radical 3. Ah, good. I know I did it right now. So see how I can use this to check my answers. All right. Quadratic formula. If we need to find an exact answer and we can't factor, we may want to use the quadratic formula. If a is not equal to 1, see how this a value is not equal to 1, or b is an odd number, completing the square is more difficult. It's not impossible. I'm sure most of you could do this problem by completing the square. But wouldn't it get a little bit difficult since x squared has to have a coefficient of 1 to complete the square? It's just not my favorite choice. Sure, I can do it, but why? It's not necessary. Because I would get 3 halves here, and then I'd have to take half of 3 halves. What's half of 3 halves? Half of 3 halves would be, nope, half of 3 halves is 3/4. Half of 3 halves would have been 3/4. And then I would have to square that. What's 3/4 squared? 9/16, so I'd have to add to both sides. Do you see my point? That this would be difficult, okay? So now we're going to go ahead and just use the quadratic formula. So a is 2, b is negative 3, c is 4. Y'all are pretty good with this, but here's the mistake I see mostly. When it's negative b and this is negative 3, what are we going to use? 3. Plus or minus square root. This squared is 9 minus 4 times a times c all over 2 times a. This is going to be 3 plus or minus. Going to go through this quickly. This is going to be 16 times 2 is 32. What's 9 minus 32? Negative 23 over 4. So here would be my final answer then. 3/4 plus or minus I radical 23 over 4. We like to split that up into the real part and the irrational and imaginary parts. Those would be our solutions. Okay? All right, last thing. When am I going to just want to start with that quadratic formula program? You know, we typed it all in, we want to use it. Well, we're going to want to use this when we have a word problem, or when the directions say just find an approximate answer. That program is a great choice because it's going to give us approximate answers. This would be an example. A juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above ground and has an initial velocity of 30 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. Here's our formula, and I would give that to you on the test. You might tell me where to plug everything in. What's the height at the end when he catches the ball? No? 3. So we have 3 here, negative 16t squared. V sub O is the initial velocity. What is it? 30. H sub O is the initial height. What is it? 4. If I'm going to use the quadratic program, though, what am I going to have to set it equal to? 0. Okay? Because this is asking me to find out how long this takes for this to happen. So if I just get it set equal to 0, now I can use my program. I'm also going to show you another way you could do this problem. But I go to my program, my A value is -16, B is 30, C is 1. Here are my two answers. Which is the correct answer? 1.91, right? Because I can't have a negative time, so the time it's going to take is approximately 1.91 seconds. Now, some people had a hard time putting this program in their calculator. Let me show you another way you could have done this. Let's say you never did get the program in there. Go to y equals. This is 3. This is -16x squared plus 30x plus 4. Going back to the original, I want to know, when is this equal to 3? I'm going to graph it. There's y equals 3. Here's my parabola. I want to know, when does that juggler catch that ball at that height of 3? Second trace, calculate what? Intersection. Go down to that. Enter. Get over there close to that. Enter, enter, enter. And see how we get the same answer. We have 1.907, which is 1.91. Same answer. Okay? So we have all these tools we can use. Learning when to use the appropriate tool is what's necessary. Right? We can use a lot of different tools, but using the best one is going to save us time. Carson?
So you could just use the equation on the calculator for any word problem you have. So we're watching the word problem.
As long as the directions say round to the nearest hundredth or to the nearest tenth or something like that. And that's, I've never seen one of our word problems that says to find the exact time, because it doesn't make sense. Like this exact time might be, 1 minus radical 3 or something. It's not, because that would be negative. But you get the idea. Like we would never want to give an answer like that when we're talking about time. So yeah, always use the program on word problems. Or you can use the, y equals on your calculator. That'll work too for the word problems. Any other questions? All right.